Okay, so related rates this is what we're going to do. They're word problems, and they're called related rates because you're going to combine a couple rates because they're related to each other. And this is where maybe we actually really start understanding what a derivative means. Okay, Lauren?
Sorry.
That's okay. This is so weird. Okay, a small balloon is released at a point 150 feet away from an observer. It's going to be like max mins, but a little bit easier. The observer is on level ground. If the balloon goes straight up at a rate of 8 feet per second, how fast is the distance from the balloon to the observer increasing when the balloon is 50 feet high? So first, I just read it. And I'm going to read it more carefully now. I have a balloon. We're going to release it. This is 150 feet. So label that. We label things that are constants. That's not going to change. Okay, then we're going to read some more stuff. Okay. So if anybody wants to use this.
We'll take it. Right, Haley?
You're right in front, though. It should be something far away. Okay. Now, we're on level ground. They're not going to make anything complicated here. And it says the balloon is going straight up at a rate. That is a velocity. Rate is a ratio. A rate is a derivative. At a rate of 8 feet per second. How fast is the distance from the balloon? So we're going to take a snapshot. I don't think I can freeze that, but we'll take a snapshot, and the balloon's going to be right here. How fast is the distance Are you touching it? Oh, I'm missing a marker. You're right. I set it down. Okay. That's interesting. Okay. So my balloon is right here, and I want the distance. It says, how fast is the distance from the balloon to the observer increasing? That's this distance. You see, at some point in time, the balloon's up here. And it's going to go up here. So this is always changing. So we're just going to take a snapshot, just a quick picture of this distance. Well, I don't know what you want to call that distance. There are two things that are changing in time. This distance is changing. What would you like to call that? H. Okay. And this distance is changing. What would you like to call that length? Q? Okay. We end up with DQ. Who's bringing the treats?
Oh.
Yeah. Okay. And here's the secret to doing these problems. Sometimes, by the way, you get a point for basically showing this. What is it you want to find? What is it that's given? And when does it happen? If you go to your last sheet on your handout, it gives you all all the steps to go through. Okay. So what's the 8 feet per second? That's given. And put your units in. If they don't ask you for units and you do it incorrectly, you're fine. Or if you don't put units in at all. But if they do ask you for units, you got to make sure they're correct. Sometimes they do, sometimes they don't. Last year, they never asked for units at all. Now, it says it's rising straight up at a rate of 8 feet per second. What is this the change in? It's the change in this height. See that? The balloon's starting here, it's going to go up. So it's the change in the height. So that's dH dt. See what I'm talking about when I talk about with respect to? It's how the height changes as time changes. What do I want to find? How fast is the distance from the balloon? That's the change in this one, right? So that's what? The dq dt. So we're going to find a relationship between q and h. That's why they're called related rates. It's almost always geometry unless they give it to you. So, and when do we want to do this? When the balloon is 50 feet high. So what's 50 feet? That's right. So often they give you a point for basically saying this. They don't look for the find, given, when words, but they're looking for you to realize that the HCT is 8 feet per second. Okay, now look at the triangle. I'm going to pull it out of there because there's too much going on. Here's H, here's 150, and here's Q. What's the relationship between those guys? You know this one. Yeah, it's Pythagorean theorem. So I'm going to write that down. H squared plus 150 squared equals Q squared. We only know H at a particular instant. The problem is we could have this situation or we could have this situation. This is changing. That's why, in a way, that's kind of nice to see the balloons moving there, because it's always changing. I'm going to take a snapshot. So I don't know what H is. I'll have to put that in later. I'll take the picture when H is 50 feet high. But to do the problem, if I make it this 50, then I'm going to have 0. And we aren't going to get zeros. Okay. So we want to relate the rates. So what do you think you have to do with that equation? Yeah, take the derivative. ddt. And they're always going to be, since they're rates, they're going to be time. Now, I'm going to do it implicitly. Some of you may want to take it, square root it. Don't square root both sides. It's too ugly. What's the derivative of h squared? 2h times, chain rule, the h dt. What's the derivative of 150 squared? 0. Should be doing the problems with this. Equals, and the derivative of q squared is 2q times dq dt. And I like to get rid of the 2's because I can. So let's get rid of the 2's. They're going to cancel out, right? And then you guys are not real good with the algebra, so let's put the numbers in now. What's h? 50. Do I know dh dt? Well, we're going to go back up and look. Oh, I do know. It's 8. This is feet. This is 8 feet per second equals q. I don't know q at the moment, times dq dt. If I can find out what q is, because now I'm going to look at the 50, and hopefully not trip. But this is, I'm going to show you a little trick too. This is 50. This is 150. I need to know what the distance is at that precise point. Yeah, it's Pythagorean theorem, but I don't want to square 50 or 150. I don't think you've seen this, but it's called the principle of the reduced triangle. What I'm going to do is make a similar triangle, but 1/50th of the size of that. So I'm going to divide by 50. This is 1, and this is 3. So in my little triangle, Pythagorean theorem we can do in our head. 1 squared plus 3 squared is what? 1 squared is 1, 3 squared is 9, so it's 10. So this is the square root of 10. To get back to the big triangle, this one's 50 times bigger, so this is going to be 50 times the square root of 10. Ever see that before? Kind of nice. It might be helpful on the ACT or SAT, I don't know. Sorry. Okay, so I'm going to put, now could you go to decimals? Sure, you could use decimals, so it's no big deal. You can use a calculator. So it's 50 times the square root of 10. But just like math meets, everybody takes, all the kids take out their calculators and they're punching it away, and I'm doing the problems, and I go, what are you using a calculator for? I don't know what the calculator tells them. Maybe that's just the difference in the way we were brought up. Okay, I want to solve for dq dt, so I am going to divide by 50 times the square root of 10. And that was feet, by the way. So I'm going to do the feet there too. just so we see what our units are going to end up being. What's going to happen to the 50s? They're going to go away, and I'm left with 8, and the feet go away too, over square root of 10, and this unit's still here, feet per second, which should make sense. Now, I use the units to tell myself what some things are at times, so you'll see in the next example. That's all there is. No, we never have to do that. If you go to decimals, you must have at least 3 decimal places. I would leave it exact. Only reason why you would have to do that would be if this is multiple choice and you had to match it. This would be a multiple choice type question. This is too easy for it to be the free response. The next one's closer to a free response. And you will see them. Because it said in the problem, it says the balloon is going up at a rate of 8 feet per second. So that's the change in h as time changes. You want to think of it as change in h over the change in time. That's 8. But we're going to do this instantaneously. That's why we have to have a little d instead. And that's what a derivative means. It's a rate of change. I'm going to write that again. Rate of change. This is how the height changes as the time changes. Rate is a ratio. You're always going to have something per something. Well, let's try another problem. Do you guys see that okay? Because we can close the blinds. We were trying to find, if we go back, it says how fast is the distance changing? Yes, I want the derivative. Remember, that's a velocity. Derivative is a velocity. Okay. You guys know what a cistern is? It's a well. When I lived on my farm, I had a cistern, and it just collects water. Except it dried up. Okay, so water is pouring into a conical cistern at the rate of 8 cubic feet per minute. Well, let me underline that. If the height of the cistern is 12 feet, so they're saying that this distance here is 12 feet, and the radius is 6 feet. And I'm going to get this water. That's the best I could do for finding water. This is 6 feet. How fast is the water level rising when the water is 4 feet deep? There's a lot of stuff going on. We're going to have to relate something here. So when I'm looking at this, I have how fast is the water level rising. Some point in time, let's take a little snapshot. There's the water. We'll call this distance h. Is that okay? What else is changing? If the height's changing, what else is changing here? The radius is changing as well. Call that r. At the top, only at the top is it 6 feet. It's not 6 feet radius down here. Okay, so now that I've got some variables here, the water's 4 feet deep. It says how fast is the water level rising? What is it I want to find? How fast is the water level rising? The change in the height or the change in the radius? How fast is the water level rising? The height. So that's the change in the height as time changes. It's all going to be derivatives. And what is it I'm given? I'm given this 8 cubic feet per minute. What is feet, cubic feet? That's volume. So this is the change in the volume as what changes? Minutes is time. So see, it kind of tells me what to do. And it says when the water is 4 feet deep, h equals 4 feet. And now I can look over here and I can figure out what it is I want to relate. I want to relate the volume with the height of the cone. And they will give you the formula. You do not have to memorize it. Does anybody know the volume of a cone? 1/3. pi radius squared h. Now, to me, this is, but they'll give it to you because they don't want to see you get it wrong because you didn't know the formula. So that's going to be nice. I want to relate v and h because that's what's in my given and find. And sometimes they tweak it a little bit so it doesn't work, but most of the time it does. I want v and I want h. R is changing as well. I do not, you can't put 6 in because the radius is not always 6. I have to eliminate the r's. I want the v and the h. Okay, so now we got to go up here to our picture. And it's not Pythagorean's theorem. I'm going to pull this triangle out. Okay. This is 6. This big height is what? 12. This little height is h. This little radius is r. We have similar triangles. Do you remember similar triangles? Yeah, they're proportional. So 6 divided by r, so this is the big radius to the little radius, is the big height, which is, what's the big height? 12 is to the little height. No, it's h. It's only for at one instant. I can't put those numbers in until the very end. It's changing. It's always changing, so you can't put the 4 in now because then you're going to have r is equal, or h is equal to a constant, or r is equal to a constant. And when I have constants, the derivative of a constant is 0, so you can't do that. So I would like to get rid of r squared, so why don't we cross multiply this? So 6h equals 12r divided by 12. R is equal to h over 2. So I'm going to put that back into my volume formula. And I am not going to take a derivative until I get this as simple as I can. If I took the derivative as written, I'd have to use the product rule. And I have to know what dr dt is, which I can get from that, but that's too hard. Let's just get rid of the r's. It's 1/3 pi, and then in place of r, we're going to put in h over 2. Okay? Can we simplify that? I don't want to take the derivative. I have to use the product rule. I'll be upset with you if you do that, because it makes my life so much harder. V is equal to, why don't you square the 2? 4. 4 times 3 is 12. So it's pi over 12, which is just a constant. And how many h's? I just multiplied it out. It's 1/3 pi h squared over 4 times h. So I combined all these guys because I have to square this. Remember, it's r squared. Okay, now we can take the derivative. Now it's easy. Getting there is not necessarily so easy, but the calculus is usually the easy part. So we'll take the derivative with respect to time. Let's pull that through here. So I get dv dt is equal to pi over 12 times the derivative of h cubed, which is what? 3h squared times, chain rule, the change in h with respect to time. And I think I'm going to clean that up before I start putting some numbers in. Because can I reduce the 3 and the 12? Yeah, that would be nice if I did that, wouldn't it? So it'll be pi over 4, right? h squared dh dt. Now I'm going to go back up here and see what I've got. I have dv dt is 8. It's too complicated if I put the units in.
Question?
Yes.
You don't do like the pi. You don't do
It's a constant. Remember the derivative of some constant times f? dx is equal to the constant times the derivative of f with respect to x. Because it's plus f times the derivative of my constant. But what is my constant? What's that?
basically
Only to the variables. Right. That's why you can pull this right through. Because when you do the product rule, you have plus f times the derivative of the constant, which is 0. I pulled the operator past the pi over 12, pi over 4.
Oh,
So I just took the derivative of that.
Yeah, you brought it down. Okay.
I just ignored it. Well, it's still there. I just don't, I could take the derivative of this. Then it's going to be 3h squared times pi over 12 plus, then it's h cubed times the derivative with respect to time of pi over 12. What's that derivative equal to? That's the product rule. 0. Product rule. That's 0. Not the first part. Okay, what's h? 4? And we have, don't forget to square it, times dh dt. Simplify before I try to solve. 4 into 16, that leaves me 4 pi times dh dt. And then divide by 4 pi. Eight was the change in the volume. I got it right out of my statement right up here. dv dt is 8. That's why I do that, because then I don't lose things. It's squared. 4 squared is 16.
Yeah. So we didn't write 16.
Not to the very end. This is the very end. Once you can't put the 4 in before you take the derivative, because then that makes everything a constant. But after you take the derivative, I can now put in the constant, the 4. Because that's the instant. I wanted it at that instant. I could have done it at the height of 1 or whatever, wherever I wanted to do it. And it doesn't matter if you reduce that, by the way. I mean, I'm going to. It's 2 over pi. We have some worksheet problems. I have to go get the worksheet. I don't know if it's there. I just divided this, but you could leave it. What's 8 divided by 4? I divided by 4 pi on both sides.
So we don't have to like solve.
You have solved it.
What?
You have solved it.
But it's how fast.
Yep. It is. It's 2 over pi, whatever that is. Feet per second or feet per minute. The change in the height. How fast is the height changing? Yes.
Oh, 4 squared.
I squared it. This is 16. 16 divided by 4 is 4. You could show all those steps. What? No, you missed me. I said 4 squared is 16. Divided by 4 is 4. So the problem is you've got to be just right there all the time. It's the same thing with reading your book. You have to read every single word. It's the same with these problems. You got to read every single word. Okay, ready? I think I got another one.
Yeah. One more.
Why don't you guys try this one? Assuming that a soap bubble retains its spherical shape as it expands, doubt it does, but how fast is the radius increasing when the radius is 2 inches? Air is being blown into it at a rate of 4 cubic inches per second. There's a hint with the units.
A soap bubble.
So you're going to have to look at what? What's cubic inches? Volume. Does anybody know the volume of a sphere?
4 pi.
4/3 pi r
Cube.
And if you ever want to be on Jeopardy, these like the equator, it's called a great circle.
Oh my gosh, yeah. That would be so funny.
Yeah, you'd have to have English.
You have to know.
The math is really easy on Jeopardy. I love it when they do the math, but they don't do that very often. But they did have a question on what that was called. That's called a great circle. It's the biggest circumference you can get on a sphere. Because you could do this, right? can put a little circle there. This is the biggest one. It's called the great circle. The surface area is equal to 4 great circles. So it's 4 pi r squared. But you could know that because if you take the derivative, you'll see it. So give it a try. Lauren's going to try and write it down on the iPad. Now you can change, pinch it. If the radius is increasing, this is a positive sign. The Pythagorean theorem was I really can't do signs. It all depends on how you draw your triangle. Unless the height's going down, then that would be negative. So if it were decreasing, it would end up being a negative number. So that, yes, these have signs to them. Number 1, I need a worksheet. Two men start walking from the same point. One goes north. One goes east. Okay. Well, north isn't quite north. Okay. This is number 1. We actually don't need calculus, but we're going to use calculus. How fast is the distance between them changing after 8 hours? So I want this distance. What would you like to call that length? Okay, you guys. This is changing. Call that x. Call this y, because I'm in the coordinate system. What do you want to call that length? H. Okay, works for me. You want to call it r? Fine. You can call it anything you want. Doesn't matter. They're all changing. Right? This one's changing. It's growing. He's walking this way. He's walking this way. What happens to the distance between them what happens to the distance between them now? It gets longer, right? Well, it's just changing. So what is it I want to find? How fast is the distance between them changing? So that's the change in what? Yeah, with respect to time. What is it I know? Jason, what do I know? Get your worksheet out.
5 miles per hour.
Okay, one goes north at 4 miles per hour. Okay, which one is this one? dy dt. And the other one is going east at 5 miles per hour. So your units are in miles per hour. And that is what? D what? dx dt. And you want to find out how fast dh dt is changing. That's a rate when the time is 8 hours. Okay? A little twist to it. What's the relationship here between x, y, and h? Pythagoras theorem. So x squared plus y squared equals h squared. So what do we have to do? Take the derivative now. What's the derivative? With respect to time. d dt. That's right. 2x times, don't forget the derivative of the inside function with respect to time. This is the derivative with respect to x. So then you have to take the derivative with, if you don't have that, you won't have any dx dt's in your problem. That's another problem. Plus 2y times the derivative of the inside function. dy dt is equal to 2 times h dh dt. The derivative, it's this, it's x squared. So you did the power rule, 2 times x to the first, then you have to do the derivative of that. If it had been with respect to x, then that would have been a 1, but it's not with respect to x. It's time. This is where we really start pulling that whole concept together. What's going to happen to all those 2's? What do I have to figure out? I have x times dx dt, which is what? Behind here. That's 5. plus y times dy dt, which is 4, is h, I have no idea what h is, times dh dt. After you've taken the derivative, you can put them back in. If you look at that, once the last page on it says when to do it. Always after the derivative. Okay, you guys, in the back? How am I going to find x and y? If you're traveling at 4 miles per hour for 8 hours, how far have you gone? It's 4 miles for every hour, so how far have you gone? After 8 hours? 32. That would be this side. 5 hours is 5 times 8 is 40. And then you have to do Pythagorean's theorem to get that. Well, I don't have a calculator on me. So I'm going to reduce it. What goes into 32 and 40? Because it's 4 miles per hour times 8 hours. What goes into 32 and 40? 8. So this is going to give me 4, 5, right? So that's the square root of 41, isn't it? Yeah. So then this is 8 times the square root of 41. And you guys can finish it off after that.